Rebuttal to Bev and the Try Thinking crew, Round 3, the Metaphor episode. Here's what we'll cover in this video. Math challenge. No Globers allowed, sorry. Revisit prior videos, specifically the math puzzles. Cat Vet Matt visits the Shy Drinking podcast. Hilarity ensues. Defining vertical, horizontal, and level in the real world. Super Mario Galaxy and how it relates to vertical, horizontal, and level. And let's learn some basic shapes. Part 1. Math challenge. Before we get started, let's have a math challenge, but this one is only directed at the folks who don't know the Earth is a globe. I'll ask 2 questions. Can you find the slope to a graph? And how about the perpendicular to the graph? Let's review that finding the slope of a graph is found by plotting 2 points, then counting the rise and run between them. Slope is defined as rise over run, or more technically, the change in y values, or delta y, over the change in x values, or delta x. Thus, the slope of this graph is 1/3. If you draw a perpendicular line, you'll very quickly see that the perpendicular slope is the negative reciprocal of the original slope. Thus, a slope of -3 is perpendicular to our original 1/3 slope. But what if we have a curved graph? Let's graph the function y equals x squared, the parent of all quadratic functions. Here's the question. Can you find the slope of this graph? If so, what is it? Having asked that, can you find the slope of a line perpendicular to y equals x squared? If so, what is it? Bev, I look forward to your discussion of these ideas on your show, and for all non-Glober viewers of this video, please feel free to share your answers in the comments. Part 2. Revisiting previous episodes. Remember, what started this all off was what Sarugaki presented as a proof. And it certainly looked like a proof, as all the steps seemed to be valid, but there was a fatal flaw. So in my response video, I included a proof that 1 equals 2. Again, it looks algebraically correct if you look at each step, and there really doesn't appear to be any math errors. But the fatal flaw is that I'm dividing by 0 after camouflaging 0 in the form of a minus b. In my second video, I presented the famous Monty Hall problem, where you're on a game show and you pick one of 3 doors, and the host opens another door and reveals a goat and asks you if you want to switch your choice to the other unopened door. Again, I quote-unquote proved that it doesn't make any difference, and I even included testimonies from PhDs in math and statistics, a visual diagram, and even the word of my own grandfather. But none of this was proof at all, because the correct answer to the puzzle is you double your odds of winning if you switch doors. So what was my point by these 2 math puzzles? They were metaphors for proof which isn't proof at all. In the case of Sarugaki's quote-unquote proof, the fatal flaw is the words horizontal and vertical, which aren't defined in Euclidean geometry at all. As I've said many times, one of the great things about geometry is the infinitely scalable nature of the theorems and diagrams. So while Sarugaki's diagram is indeed true on the local scale, it cannot be scaled to cover large distances, because vertical is defined as aligned with plumb, and plumb changes across the Earth. Part 3. Cat Vet Matt visits the Shy Drinking podcast. Okay, for a bit of fun, we'll eavesdrop in on a conversation that the Shy Drinking podcast crew had with a fellow named Cat Vet Matt.
So I was saying, cats aren't the only 4-legged mammal that people keep as pets.
What? You're saying that cats aren't 4-legged mammals?
Nonsense. It is impossible.
That's not what I said at all. Sure, cats are 4-legged mammals. No argument there. But all I'm saying is that cats aren't the only 4-legged mammals that...
You just said it again. Cats definitely have 4 legs, and they are mammals, every one. What kind of veterinary school did you go to?
You bloody veterinarians are all the same.
Don't they teach you that cats have 4 legs?
That would be a violation of the law of identity.
I'm fascinated by the psychology behind Cat Vet Matt saying that.
And you call yourself a cat vet? Imagine being a cat vet and not knowing that cats are four-legged mammals.
I hope the gag is obvious. Lev is reversing what Cat Vet Matt is saying and then taking that obviously false idea to absurd lengths. It's a metaphor for my saying that while vertical and horizontal are in fact perpendicular, not all perpendiculars to a horizontal are vertical. But this has been turned around as me having a problem with the perpendicularity of horizontal and vertical, or with perpendicularity in general. Let me be crystal clear. Horizontal and vertical are in fact straight lines, and horizontal is perpendicular to vertical. Full stop, no exceptions. Part 4. Defining vertical, horizontal, and level. Here's a question. Do you agree with these two definitions? Vertical is aligned with plumb. The string of a plumb bob at rest is vertical. And horizontal is a straight line or flat plane that is perpendicular to vertical. In other words, a line or a plane perpendicular to the string of a resting plumb bob is what we call horizontal. Now for the third definition. Level is very similar to horizontal in that it is perpendicular to vertical. While horizontal is a ruler straight line, level is smoothly continuous. I hope you agree with what the Civil Structure website has to say in that a level surface is perpendicular to gravity, and that the surface of still water is level, and that a level line is normal or perpendicular to plumb. Can we stick with these three definitions? Vertical is aligned with plumb, horizontal is a straight line perpendicular to vertical, and level is also perpendicular to vertical, smoothly continuous over the earth. Regardless of the shape of the earth, these three definitions should be ones on which everyone can agree. Part 5. Super Mario Galaxy. So I'd hope you'd agree that there is disagreement about the shape of the earth. You've taken great pleasure in mocking those of us who know the earth is a globe, and you claim you're not a flat earth fellow, and it's clear that you believe that all horizontal planes are parallel to each other. A great visual example to demonstrate this difference is Super Mario Galaxy 1 and 2, originally for the Nintendo Wii and now on the Nintendo Switch. I want to make very clear that I'm only using this as a metaphor. It's a video game designed with fun in mind, and the physics of Super Mario Galaxy are cartoon physics. The game designers did not set out to simulate Earth or any other planet. Their goal was to provide a fun experience for children and adults alike. What's fascinating for me is that the levels have two different physics models. Some levels have a universal down orientation, such that all vertical lines are parallel. This matches the original design of the side-scrolling 8-bit Super Mario Bros. From the original Nintendo Entertainment System. Hitting the jump button propels you up in the opposite direction of down. You go down green pipes, and you jump up to grab the highest point of the flagpole that you can. The flagpole, of course, is oriented with vertical. But there are other levels where down is not universal, where down is in the direction of gravity, wherever Mario happens to be. And for physics fans, check out How Spherical Planets Bent the Rules in Super Mario Galaxy by Jasper on YouTube, which is where I got many of these images. This leads to a lot of fun play action as you navigate your way around spheres, small and large, around a rounded cube, and even on a stainless steel flying saucer. Down is simply towards the ground, wherever Mario is standing, and up is the opposite of down. Hitting the jump button sends Mario in the opposite direction of down. Let's explore one level where there's a universal down. You can see that all verticals, such as the tall tree trunks, are parallel, and that the different horizontal flat grassy plains are parallel to one another. It matches our two definitions of vertical being plumb and horizontal being perpendicular to vertical. There are various power-ups throughout the games, and one of them is called the spin drill. You must be standing on dirt for it to work, And when you activate your spin drill, you initially drill down until you pop out the other side. In planet Earth terms, this is antipodal. There's one level where you have to defeat a mini-boss by using your spin drill. In this mini-boss battle, they actually show a cross-section of a dirt planet, and you run around the surface strategically using the spin drill when Dig-a-Leg is antipodal to Mario. So let's freeze this scene and ask a few questions. What is vertical for Mario? What is horizontal for Mario? But what is vertical for Dig-a-Leg? What is its horizontal? Now clearly these horizontals are intersecting. What about verticals elsewhere around the dirt planet? They're all aligned with plumb by definition. Let's clean up the diagram a little bit. Mario's horizontal and vertical are in fact perpendicular, but constructing other perpendiculars to Mario's horizontal do not make verticals, since most of the places on Mario's horizontal are not aligned with plumb. To review, horizontal is perpendicular to vertical, but all lines perpendicular to horizontal aren't necessarily vertical. We can go further with this and include our third term, level. When it rains on the Bolivian salt flats, it forms a shallow puddle hundreds of square miles big, with the water at rest, or level. Here's a Mario world where he has a similar shallow puddle. Note the orientation of the flagpole, the blue button, and the green crystals, and how they're all normal or perpendicular to the surface. The water level curves around the spherical shape of the world. Level is perpendicular to plumb, but smoothly continuous with level in other locations. The Mario games are filled with environmental puzzles, such as this roughly spherical world. Mario must reach this high platform, but he can't jump that high. So if he floods the world with water, knowing what you know about gravity, can you picture what the water level will be after it's flooded? Remember that water at rest is level. Will it be in the shape of a plane? Will it look like a cube? Let's play the clip. So there he goes with his spin drill. He hits the water fills up, and it forms a sphere. The water surface is level, and he's able to grab his Power Star. Super Mario Galaxy has been played by millions of children across the globe. If they can understand the physics of gravity, so can you, Bev. Part 6. Let's learn some basic shapes. Okay, now for a bit of fun. Bev, I'm going to try to teach you some basic shapes. Are you ready? Let's go. Okay, Bev, look at this shape. What do we call this three-sided shape?
We call this a square, but...
No, a square has 4 equal sides and 4 right angles. What you have is a triangle made up of 3 sides and 3 angles. Okay, let's try again. Let's say you were matching shapes into these outlines. What would you use to fill in this triangular shape?
We'll just use the square.
Okay, you grabbed the right shape, but we don't call that a square, we call that a triangle. Okay, Bev, let's make this easy. With a square, a circle, and a triangle. We call this a square, we call this a circle, and we call this, Bev?
We call this a square, but...
Oh! Thanks for being a good sport, Bev. But this skit is a metaphor. What I was doing is very unfair and is called definition projection. Start with a word which has multiple definitions, such as square. And then when you use the term, I'm going to project upon you a different definition using my preferred definition, not the one that you had intended. A great example of this is straight line. We all know that in geometry, the concept of the shortest path between 2 points is known as the straight line. There are many ways to get from A to B, but only one of them is the shortest path. Now, in spherical geometry, or even with just a beach ball and a Sharpie marker, we can also have the concept of the shortest path. When people are talking about specifically the surface of the sphere, they may also use the phrase straight line, meaning shortest path, even though this meaning is different from Euclidean geometry. As shown in this page from the Encyclopedia Britannica, great circles are the straight lines of spherical geometry. A fellow can hold up a globe and say, draw a straight line from New York to London, aka a geodesic or a great circle route. And someone else will insist that it's not a straight line because it isn't a Euclidean straight line. It is, however, the shortest path drawn on the surface of the sphere. Parting thoughts. In conclusion, I'm hoping that we can agree upon some basic principles. Vertical is aligned with plumb. Horizontal is a straight line or a flat plane, perpendicular to vertical. And level is also perpendicular to vertical and is connected smoothly to level in other locations. Even if you don't accept that planet Earth is globe-shaped, I'm sure you can agree that level in London is smoothly connected to level in New York City. I'm also hoping that we can agree that what appears to be a proof may hide a fatal flaw. Did I prove that 1 equals 2? No, because I divided by 0 as one of my steps. Did Sarugaki prove that vertical in one location is parallel to vertical in another? No, because vertical and horizontal are not defined in Euclidean geometry, while they are defined in the real world. Vertical is aligned with plumb, which diverges on a globe with large distances. I'm also hoping that we can agree at least on the concepts of vertical, horizontal, and level using a game like Super Mario Galaxy. Note that I didn't ask you to agree that the Earth is a globe. I'm just simply hoping that using the illustration of a round world in a video game, where gravity pulls towards the center, you can understand how all perpendiculars to horizontal are not necessarily vertical on a globe, and how level is not horizontal with great distances. And don't forget about my 2 math challenges. What is the slope of the curved graph of y equals x squared? And what is the slope perpendicular to the graph? Before I go, I'm going to give you something to blow your mind, hopefully in a thought-provoking way. The Greek mathematician Euclid was a towering intellect in the ancient world, but he did not only write the book now known as Euclid's Elements, he also wrote a book called Phenomena, dedicated to spherical astronomy. It turns out, Bev, that Euclid was one of the fathers of spherical geometry. But it gets better. In the preface, the authors explained that Euclid's phenomenon belongs to a branch of ancient mathematical sciences that the Greeks called spherics, whose purpose was to explain the geometry of the celestial sphere and its circles, as well as the consequences of that geometry for observers on a spherical Earth located at the center of the celestial sphere. If you like this content, please leave a like and share. And as always, please be kind in the comments. Bye.